Hi everybody, this is Usha, Assistant Professor, Department of MCA, Fatima College. I'm here to give you a short introduction about the IEEE 802.11 standard. So what is basically IEEE 802.11? So IEEE 802.11 is a standard which is initiated by the Institute of Electrical and Electronics Engineers, which is a forum, and this standard is for developing a medium access control and physical layer specification for wireless connectivity for all kinds of networks like fixed, portable, and moving stations within an area. Basically, IEEE 802.11 is referred to for wireless LANs. So the IEEE first approved this standard as an international interoperability standard for wireless LANs. Okay, so it is going to use 2.4 gigahertz industrial, scientific, and medical radio band, and it provides a mandatory 1 Mbps and an optional 2 Mbps data transfer rate. So this is about the history of IEEE 802.11. Now coming to the architecture of IEEE 802.11, that is the architecture of wireless LAN. So what actually happens? So when you say it is a wireless LAN, the nodes are going to be mobile. So the nodes can move or they can be mobile within a particular range. So how the connection takes place? So the mobile nodes gets connected to the fixed network through an access point. So there is an access point on a wired network, and the mobile nodes in and around a particular area gets connected to this access point on a wired network, and only through this access point it gets connected to the network. Okay, so this access point is going to allow the establishment of a peer-to-peer connection. So normally there are two types of standard defined for this wireless network topologies. One is the infrastructure mode and the other one is the ad hoc mode. Infrastructure mode is the standard which defines the basic service set, which is abbreviated as BSS, and the ad hoc mode is going to be defined as an independent basic service set, which is called as the IBSS. Now coming to infrastructure network. Infrastructure network extends the range of the wired LANs to wireless cells. So there will be a wired LAN and you'll have some cells which goes wireless, and that is called as the infrastructure network. So a stationary device is a part of your wired networks architecture, and it provides network connectivity to the mobile devices, right? So you have both fixed as well as mobile devices, and there will be a stationary device which is connected to the wired network infrastructure, and this stationary device provides the network connectivity to the mobile devices. So this access point is the stationary device, and this is going to be the bridging point between the wireless and the wired devices. So the area covered by an access point is called as the cell, right? So an access point can cover a particular range of area, and the area covered by this access point is called as the cell. So you'll be having a wireless network interface card, or other mobile devices will be having some wireless network connectivity, and those devices which are in that particular range of a particular access point, then they can get into the network. They'll be able to get the network connection. So to summarize, you have both wired and wireless devices. Okay, so both fixed and mobile devices. And the fixed devices, you have a stationary device called the access point, and this access point is the bridging point between the wireless devices and the wired network. So the area of coverage done through the access point is called as the cell, and this access point acts as the bridging point between the wired and the wireless devices. So this is the concept of infrastructure network. And look into this in this picture. You have several laptops and personal digital assistants over there. They are all mobile devices, and the area covered by all these mobile devices is called as the basic service set. And you have an access point over there, and this access point is connected through a wired network hub to the wired LAN. So the mobile devices are able to access the network only through this access point. So they are in the network only through this access point, which is a stationary device. So this is the infrastructure of the basic service set in an infrastructure model, right? So the collection of all BSS of an infrastructure network is called as the extended service set. You will not have just a single BSS, but you will have some collection of BSS, and all the collection of BSS are termed as extended service set. So each BSS network has a range. If the coverage areas of the different basic service set are going to overlap each other, then it is possible to move from one cell to another without losing the network connection, and thus a broad network coverage can be achieved. So you have two BSS overlapping each other. In that case, you can move from one cell to another without losing the network connection. So it is used to replace the wired connectivity within a building or within a campus area. So this is also called as extended LAN infrastructure. Okay, so this is how things goes. So you are inside a building, you have mobile devices as well as the mobile wired devices. So you have wired devices fixed in a particular place, and the mobile devices roam along the campus. And now all these mobile devices can get access to the network, that is the wired network, through this access point in this coverage area. So that is called as the extended service set. Okay, so this is the extended service sets infrastructure. So you have several basic service sets, and you can see the top two are overlapping each other. So if the laptop is taken from the top one to the next one, the middle one, there will be no losing connectivity. Okay, and in the second case, if you want to move from the second to third, there might be a loss of connectivity for a short period of time of transit from the second to the third. But every basic service set is having an access point, and only through this access point you are able to connect to the wired network hub. So this is the ESS infrastructure. So what are the various mobility types available? You have three different types of mobility available, you are capable of moving in three ways. One is no transition. So in this type, the stations will not move, and if at all they move only within the particular basic service set. They move only within the particular BSS. So that is called as no transition. And the next comes the BSS transition. Here the mobility refers to the stations moving from one BSS to another BSS, but within the same ESS. So only within the same extended service set you will be moving from one BSS to the next BSS. This is called as BSS transition. If suppose you have two different wireless LAN and wired network connections, and you move from one ESS to another ESS, right, then it is called as ESS transition. So you are moving from one BSS of an ESS to another BSS of another ESS. So that is called as ESS transition. These are the various mobility types that has been defined in IEEE 802.11. So how the physical configuration takes place. So the basic service sets are partially overlapped. As you have seen in the picture, the top one and the middle one were partially overlapping. So this type of configuration is going to give you a contiguous coverage within a defined area. So this is best if the application cannot tolerate a disruption of network service. If you want the network service to be continued always, you need overlapping of BSS. And the next type of configuration is where the BSS are physically disjointed. You could see in the picture the second and the third. So in this case, the configuration does not provide contiguous coverage. There will be some disruption in the service. The third ones are BSS which are physically co-located, which means that it may be necessary to provide a redundancy or higher performing network, right? So these are the three different types of configuration available with the BSS, right? And now coming to ad hoc network. So what is ad hoc? Infrastructure network, you had a wired network and you had an access point which connects the wired network to the wireless network. And coming to ad hoc network, this is completely wireless. You don't have a wired network at all, and there is no need for an access point to interlink with the wired network. Each node in this network is wireless completely. So each client communicates with the other client within the network directly. There is no access point. So ad hoc mode is designed in such a way that only the client stations within the transmission range or within the cell can communicate with each other. So only the nodes within a particular cell can communicate with each other. So this is the topology of your independent basic service set. So as I told you before, in case of ad hoc network, the structure is called as independent basic service set. So you have a basic service set here where every node is independent to each other. If at all laptop 1 wants to connect to laptop 2, it has to directly communicate to laptop 2. So there is no access point to interlink to the network. So everybody within the BSS gets connected to each other directly. So this is the topology. And if the client want to get connected to a node in another cell outside the cell, so how it will happen? In that case, you had an access point. In the infrastructure mode, you had an access point, so you'll be able to communicate to the other cell through the access point. Here there is no access point. So if a node in a particular cell wants to get connected to the node in another cell, what has to be done? A member of that particular cell should play the role of a gateway, and it has to perform the routing. So one member of the cell should operate as a gateway, and it has to perform the routing. So prior communicating the data, the wireless clients and the access points has to establish a relationship called as association. So both of them has to associate with each other. Only after the association is established, the two clients will be able to communicate with each other. This is the case in the infrastructure mode. So the clients gets associated with each other through the access point in the infrastructure mode. But in case of the ad hoc network, what happens? The association process has three states. One is unauthenticated and unassociated. The second is authenticated and unassociated. And the third is authenticated and associated. So in order to change the association states, the communicating parties should exchange messages with each other, and these messages of this kind are called as the management frames. So coming to the first state, unauthenticated and unassociated, nobody is authenticated, nobody is associated with each other. Randomly they transfer messages. That's the first case. And the second case, everybody enters with an authentication, but they remain unassociated. And the third thing is where both the things happen. That is, all the clients that communicate with each other are authenticated and associated. So this is all about the ad hoc network. So we have learned the basics of IEEE 802.11, that is the wireless LAN architecture, and the two different modes of processing. One is the infrastructure mode and the other one is the ad hoc mode. So thank you. Have a good day.